Okay, good morning. The video that you're going to see is a 4-4 extension. So there's 4-4 in the book, and this is one more concept regarding that. So the two concepts that we are going to be talking about are the angle bisector theorem and the perpendicular bisector theorem. So what is the perpendicular bisector theorem and what is the angle bisector theorem? That's what we're talking about. So the first thing we're going to mention is the perpendicular bisector. I like this because it has a lot of syllables in it. Perpendicular bisector. That's like there's a lot of syllables. So it's fun. All right, perpendicular bisector theorem. Okay, and so remind ourselves what a perpendicular bisector is. This is a segment, a seg, that is perpendicular and bisects, perpendicular to and bisects another seg. All right, so perpendicular bisector might look something like this. So this is A, B, C, D. All right, and AD is the perpendicular bisector of CB. So what that means is AD is perpendicular to CB and AB bisects CB. So angle A, I guess I can put a D there. So let me put an E right here. So angle AEB is congruent to angle AEC, and both are 90 degrees. Okay? And CE is congruent to BE. So we bisect. So we have a midpoint. E is the midpoint. Now that's just what a perpendicular bisector is. But what is the perpendicular bisector theorem? Okay, what does it mean? What does it say? Okay, the perpendicular bisector theorem is that if a point is on this perpendicular bisector, it's equidistant from the endpoints of the segment. So if a point is on the perpendicular bisector, now in this case, that's AD. So if any points along that, right, any point along that, if a point is on the perpendicular bisector, okay, of a segment, all right, of a segment, then it is equidistant from the endpoints of that segment. It is equidistant from any point from the end, not any point, but any point on the perpendicular bisector is equidistant from the endpoints of that segment. Now I like to call this segment, I like to call this the bisectee. So I like to call that the bisectee. So the segment being bisected, if any point along the angle bisector, the perpendicular bisector, is equidistant. So what that means is this. So I'm going to do that same kind of segment again here. And this is A, this is B. Was it C? No. A, B, and then CD here. So we have the perpendicular bisector. So AD is a perpendicular bisector of CB. Now, any point along that, this is what the perpendicular bisector, let's say I have, this is point E right here, don't forget. Let's say I have a point along this perpendicular bisector. I'm going to call it F. Any point along this is equidistant from the endpoints of the segment. What that means is if I pick a point F and I draw that point to C and draw that point to B, that means that these two segments are congruent. So what that means is if F is on AD, right, then FC is congruent to FB. That's the angle bisector. That's not the angle bisector. The angle bisector is the next theorem. This is the perpendicular bisector theorem. And the perpendicular bisector theorem says if a point is on the perpendicular bisector, it's equidistant from the endpoints of the segment. So if F or any other point, I'm just going to do, let's say, another point G, okay? If I do G, G is equidistant from C and B. Okay, and I could keep going if I wanted to. I could pick another point, like H. And if I put H on the perpendicular bisector, then HB is congruent to HC. All right, the same with this one. GC is congruent to GB. So if a point, and I did 3 points, on a perpendicular bisector, it's equidistant from the endpoints of that segment. That's the perpendicular bisector theorem. It's a pretty good one, okay? Now, the same is true for the converse. So the converse is true. And the converse is if a point is equidistant from the endpoints of a segment, okay, so it would say something like this. If a point is equidistant from the endpoints of a segment, if a point is equidistant from the endpoints of a seg, it's that point I'm talking about, it's on the perpendicular bisector of that segment. Okay, so it's the opposite is true. All right? Now, so what that means in terms of our problem, if, for example, for problems like this, you might have a diagram that looks like this, and then you have a segment that looks like this, okay, and then you have a perpendicular right angle there, and you have a bisector here, and then you have, let's say, a point right here, and this is 7.3. And the question is, what's this? Well, we can see that this segment is a perpendicular bisector because it's perpendicular to this segment, and it bisects the segment. So this point is equidistant from this endpoint and this endpoint, that makes that other length 7.3. So we know from the perpendicular bisector theorem that it really creates an isosceles triangle, okay? So this creates isosceles triangles, which is kind of cool. Okay, so perpendicular bisector theorem. Now, the next theorem is the angle bisector theorem, which is another really cool theorem, okay? So the angle bisector theorem is, if a point's on the angle bisector, it's also equidistant, okay, from the sides of the angle. So if a point's on the angle bisector, then it's equidistant from the angle, the rays of the angle, okay? So the second theorem about this is the second 4-4 extension theorem. Is the angle bisector. Theorem. All right? So the angle bisector theorem is, that's the bisector theorem. And the angle bisector theorem says that if a point is on the angle bisector, is on an angle bisector, okay, it's equidistant okay, the right angle distance from the angle, from the sides of the angle. Okay? So what that means is this. Here's an angle. All right, and here's an angle bisector. So I'm going to put an A here, B here, put a C here, and a D here. Okay, so BD is the angle bisector of angle ABC. So AD, all right, now AD is right here, is congruent to CD, which is right here. Now, the right angle distance, okay, so this segment is perpendicular to the side of the angle, and this segment is perpendicular to the side of the angle. So this segment is congruent to this segment. Now, this is not a midpoint because this whole thing is not a segment, like this is not a segment, all right? So this is not a midpoint. But if a point is anywhere along this angle bisector, let's call it E, all right? It's equidistant from the sides of the angle. So this segment is congruent to this segment. And you could pick another point along there if you really wanted to, like this one, and just understand that this segment here is congruent to this segment here. And then, of course, this is a right angle, and this is a right angle, okay? So the angle bisector theorem says that. All right, so those are the two theorems, the angle bisector theorem and the perpendicular bisector theorem. Perpendicular bisector theorem, okay, and the angle bisector theorem. All right, angle bisector, perpendicular bisector. All right, ciao.